Alright. You win. You've been asking for a tutorial about animating stuff with comfyui for a long time now. So let's see how to turn this Blender animation to this Stable Diffusion animation. Or this one into this one. Or this one into that one. So using these workflows and the theory behind it is not that hard. We start from a scene in Blender, we export some keyframes, then we use those keyframes to turn them into generated images that we like and are coherent, and then we use all those frames one by one as a base to generate the animations. I always shied away from doing animation tutorials because it's incredibly time consuming and it's not easy for everyone. But a couple days ago, Matteo, the dev behind IPAdapter Plus and his YouTube channel Latent Vision, which I highly recommend, came up with a workflow for using IPAdapter in an AnimateDiff environment. I'm gonna leave his video in the description below, and this workflow starts from their work. But the way that Matteo is doing it is by generating different images, different views of the same character, whereas I thought, why not take care of that inside of Blender or inside of any other 3D app? Because at that point we already have a reference and we can direct it. We have much more control over our own art direction rather than depending on random generations for poses or depending on already existing videos. So today's tutorial starts from Blender for animating and exporting the keyframes. Then it moves on to a first very simple workflow that turns those keyframes into an image that we already like and we want to use for the animation, and then uses those Blender keyframes turned into generated images as keyframes for the final animation. The reason why I like this workflow and I thought of it as such is that I don't like using software like EBSynth or Adobe After Effects. Instead, with this workflow, we only need to select some keyframes and then run them through an AnimateDiff pipeline, and we get the actual animation right off the bat. As always, you'll be able to find all the workflows and the models that I'm going to use in the description below. You can install any missing custom nodes from the comfyui manager. And now we are going to build everything from scratch. So if you want to just jump ahead and see how it works and how it comes together, you can use the timestamps in the description below. So before setting up anything with comfyui, for this tutorial, we are going to need a mixamo animation. You can find the link for the Adobe Mixamo website in the description below. You can just go ahead and select a kind of animation that you like, and you are going to want to use this base model because it looks like a dummy human and it works really well for Stable Diffusion. Once you've found the animation that you like, we're going to go ahead and download it. We are going to download it as an FBX, and then we are going to open Blender. Inside of Blender, we are going to bring up the timeline a bit, and we're going to delete everything but the camera. Next, we are going to import an FBX, which is the FBX of the model and animation that we just downloaded from Adobe Mixamo. And next, we will have to fix some settings for this to work. So the resolution of the renders is going to be 512 by 512. The render engine is going to be cycles. I'm going to switch from CPU to GPU compute, and I'm going to lower the max samples to 1024 because I don't need as many samples for my final render. Next, I'm going to switch the viewport to render view. Now everything is dark because we don't have a light source, so for this example I'm going to search for an area light, place it on top of our character, bring it forward a bit, and then up the power a bit. I am also going to hide the armature because I find it distracting, and then I am going to set up my camera from my point of view, which is Control-Alt-0. Next, I'm going to fix my camera, and then I'm going to bring up a torus, rotate it on the x-axis, 90 degrees, bring it back a bit, go back to my camera view by clicking on 0, and then bring it up on the z-axis. I'm going to right-click on it, select Shade Smooth, and then I'm going to create a new material and select Emission. I'm going to up the strength on the emission material to create some nice contour lights around the subject. Then, in order to help Stable Diffusion understand what's going on with the hands, I'm gonna add another area light in front of the subject. So I'm gonna bring it forward, rotate it on the x-axis, and bring it up a bit. go back to my render view, and now the front of the subject is not as dark. I'm gonna select my camera. I'm going to center and reframe it so that it's a nice composition. And then if we go over to the timeline and bring forward frames, we can see that the animation is running. Now, in order to get an animation with Stable Diffusion and AnimateDiff, we need some keyframes. Basically, what AnimateDiff is doing is trying to interpolate between two keyframes and understanding the action that brings from one keyframe to the other. So for this animation, we have around 92 frames. So I am going to select the end here at 92 just to remember that. And then I want to divide those total frames into a suitable number of keyframes. Now, there's no definite answer on the number of keyframes that you want. It depends on your animation. If a lot is happening frame by frame, you want a bigger number of keyframes. If nothing much is happening between frames, you can get away with less keyframes. Here, for example, nothing much is happening, so I'm just going to render every 10th frame. So in my case, that's the first frame, the 10th frame, the 20th frame, the 30th frame, etc, etc, etc. So I'm gonna select the first frame. I'm gonna go to render, render image, and wait for the image to finish rendering. And then I'm gonna save it as a source keyframe inside of a source folder. Now, I've already done this for each frame, so I'm not gonna do it again. But let's just show you with this one. I'm gonna select, for example, frame 1 and hit save. Then I'm gonna close the render view, select frame 10, and then render image for frame 10. When the rendering is done, I'm gonna go over to image, save, and then save it as frame 2. And again, it's the same for frame 3, frame 4, frame 5, etc. Once we are done, we are going to have 9 different frames in our case, showcasing the movement between each frame. Now let's go back to comfyui. Now that we have our keyframes, what we want to do is just generate an image that we like and has the style that we like based on those keyframes that we already have. So the first thing that we're going to do is just set up a basic image-to-image workflow. The first thing that we're going to do is search for a load checkpoint node, select a model of our liking, depending on what we want to have. In our case, it's going to be Juggernaut Reborn, for example. Then we are going to add a keysampler. We are going to go ahead and up the steps a bit, select a lowest CFG like 6, and then select the samplers and schedulers that we like for the kind of generation that we want. So let's say Euler and normal. Next, we're going to drag and drop from clip and select clip text and code. Ctrl-C, Ctrl-V. The top one is going to be our positive prompt field. The bottom one is going to be our negative. I'm going to connect the clip from the load checkpoint node to the negative one as well, and then the positive conditioning to the keysampler as well as the negative. The next thing that we need is a way to influence the final image starting from the keyframes that we have. So that's going to be 2 different ControlNets, one for depth and one for open pose. So I'm going to search for apply ControlNet. Then I'm going to drag and drop from ControlNet and select ControlNet loader. I'm going to select adapt ControlNet, and then I'm going to select both the load ControlNet model and the apply ControlNet nodes. Ctrl-C, Ctrl-V, and place them over here. And for the second one, select an open pose model. Next, I'm going to search for a load image node. And then I'm going to place the first Blender keyframe inside of it. Now, we already know that this image is 512 by 512, so there's no need to resize it. But I'm going to add a resize node just in case, because I know that you like copying workflows without actually thinking about what's going on. So let's going to add that. I'm kidding, but you never know. I'm going to connect the image from the load image into the image resize node. And the next thing that I'm going to do is apply 2 preprocessors, one for depth and one for open pose. So I'm going to look for depth anything and for open pose pose. I'm going to run the image resize output into depth anything and do the same for the open pose pose. And then I'm going to use the output from the depth anything node as an image input for the apply ControlNet that requires depth, and do the same from the open pose pose node inside of the apply ControlNet for open pose. Now, as you may already know, I like adding some preview images over here so that we get some nice troubleshooting and we can see if anything goes wrong. So this preview image will give me a preview of the depth anything node, and this one is going to give me a preview for the open pose. The next thing we want to do is run the positive conditioning over from the positive prompt field into the apply ControlNet node, chain both apply ControlNet nodes for conditioning, and then use the last conditioning output as a positive input for the keysampler. Next, we want to use this image as a base, so we're gonna draw up a VAE encode node, connect the image resize output into the pixels for the VAE encode node, and then hook up the VAE from our model into the VAE encode node. Then we're going to connect the latent from the VAE encode node into the keysampler, and then we are going to drag and drop from the latent output from the keysampler, select VAE decode, hook up the VAE from a load checkpoint node, and then drag and drop from image and select preview image. And that's the base for creating the first keyframe. Now you can do two things here. You can try to specify inside of the positive prompt field what you want the image to be. So for example, we might want an anime illustration of a young woman swimming underwater. And for negative, for example, we are using photo, render, 3D, not safe for work, and nude because I am on YouTube. Or what you could do is add an IPAdapter pipeline for style transfer. So let's do that. I am going to search for IPAdapter Advanced, place it right over here, search for the unified loader, hook up the model from the load checkpoint node, and then hook up both the model output from the unified loader and the IPAdapter output inside of the IPAdapter Advanced node, and then hook up the model output from the IPAdapter into the keysampler. I'm going to search for a load image node. I'm going to connect it to the image input in the IPAdapter Advanced node. And then here in the unified loader, I'm going to search for plus. And inside of the IPAdapter node, I'm going to go over to weight type and select style transfer. Then I'm going to drag and drop an image of our liking inside of the load image node to use as a base for the style transfer, and then I'm going to hit QPrompt. Now as you can see, we are getting a depth image and an open pose image, and the resulting image is based on our keyframe and on the style from the style transfer of the IPAdapter. Now we are working with a very low resolution right now, so some details such as the hands here or the arms might be a bit scuffed. So what I'd like for you to do is just to keep on generating until you get a good anatomy. And once you find a result that you're satisfied with, we're going to right click on the image and save the image as our first frame inside of a reference folder. So in my case, that's going to be frame 1. Now that we've done this for the first frame, we need to change our workflow a bit. We already have the style. We already have the first frame. The thing that we want to do is change the weight type of the IPAdapter from style transfer to linear, and then we are going to change the reference frame from the load image to the first frame that we just saved. Then we are going to go over to our ControlNet pipeline and drag and drop our second frame, and we are going to run the generation for our second keyframe. So I'm going to hit QPrompt. Now, as you can see, the depth and the pose have been recalculated and a new frame, the second keyframe, has been created. And depending on the complexity of the starting image is going to be more or less coherent with the previous frame. Once we have generated a frame that is close enough to the previous frame, we are going to select it and save it as the frame of reference. So in our case, that's frame 2. And then we are going to do the same for each missing frame. So let's say frame 3, hit QPrompt, right click, save it, name it frame 3, frame 4, etc, etc, until you got all the keyframes right. And now that we have all of our keyframes that have been rendered inside of Blender and then turned into generated images, we can move on to this beast of a workflow. So let's build it from scratch. We're gonna work with LCM since it's a lot faster than regular models and it works really well with AnimateDiff. So we're going to load a checkpoint. We are going to select our checkpoint of choice. In our case, that's going to be Juggernaut Reborn. We're going to search for a load LoRa node. We're going to select our LCM LoRa. If you don't have it, you're going to be able to find the link in the description below. We're going to hook up the model and the clip, and then we're going to search for a model sampling discrete node. We're going to select LCM and hook up the model. Now we have to solve 3 problems. We need an AnimateDiff pipeline, we need a way for IPAdapter to use our keyframes as an influence for our final animation, and we need a ControlNet pipeline to influence the animation so that the keyframes are respected. Let's start with the AnimateDiff pipeline. For this pipeline, there's some nodes and some models that you might not have. As always, you'll be able to find them in the description below, or you can install them if you import the workflow files into your comfyui instance by using the manager. We're going to search for use evolved sampling, and we're going to hook up the model. Next, we're going to drag and drop from M models and select apply AnimateDiff simple. This node applies an AnimateDiff model, but we're going to need the motion model. So we're going to drag and drop from motion model and select load AnimateDiff model. In our case, we're going to use the LCM motion model. If you don't have it, again, description below. Then we are going to need some parameters for our AnimateDiff samplers. So we're going to drag and drop from the context options, and we're going to select the standard static context options. Now, what this node does is a lot. So in case you want to know about what this does, there's a link to the GitHub in the description below. If you don't want to know, that's fine. You can just tinker with the numbers or copy mine and then be on your way with it. But what we are really looking for here is the context overlap value, which indicates the minimum common latence between adjacent windows. Since I am basing this workflow on Matteo's one, I am going to input the same settings that he is using, so I'm going to go with 6. Depending on your case, it might be a different number. And then we're going to change the scheduler here inside of the evolved sampling node from auto select to LCM average. Now the base AnimateDiff pipeline is done. Let's go with the IPAdapter pipeline. What we need the IPAdapter to do is basically create a number of frames based on our keyframes and then use those to influence the resulting images from the AnimateDiff pipeline. So what we want to look for is an IPAdapter batch node, because multiple images together are called in batch. Then we're going to search for the unified loader. Then we're going to run the model output from the evolved sampling node into the unified loader, and we're going to connect the model output from the unified loader into the IPAdapter batch, as well as the IPAdapter output. The next thing we're going to need is 9 different load images node, or a way to load all our keyframes as a batch from a folder. It's your choice. Same as Matteo, I like having all of my keyframes available to me inside of my workspace, so I'm going to use a load image node 9 times. I'm going to search for that, place it here, Ctrl-C, Ctrl-V 9 different times, and then what we want to do is drag and drop each frame inside of a different load image node. So that's frame 1, 2, 3, frame 4, 5, 6, 7, 8, 9. Then we need a way to use these images as a batch. So I'm going to search for image batch multi. This is a very handy node that takes a number as an input. In our case, that's 9, because that's 9 keyframes. I'm going to update the inputs, and we're going to have 9 different inputs. I'm going to drag and drop from keyframe 1 into image 1, keyframe 2 into image 2. Once we are done setting up our metrics of keyframes, what we need is a way to use this batch inside of the IPAdapter. So let's look for IPAdapter weight. This is a cool new toy from the IPAdapter Plus suite. And what this allows us to do is create a lot of different frames based on these 9 base keyframes. I'm going to hook up the images output from the batch node into the IPAdapter weights node, and I'm going to drag and drop from image 1 into a preview image node and hit QPrompt. Now, if we zoom in, we can see that we are getting each of the 9 frames 2 times. What this is doing is basically replicating each keyframe, but we don't need 2 of each, we need more. So let's say we want to have 6. We're going to go ahead and input 6 here in the frames. If we hit QPrompt again, we can see that we now have the first keyframe repeated 6 times, the second one repeated 6 times, the third one repeated 6 times, etc., etc. And the other thing that is really cool that's happening here that you can't see is that it's feeding all of these frames that it generated little by little, starting from white and going to black as a mask. So each one of these frames is going to be more and more fading to black as a mask. And what this does is basically blending from one frame to the other. Now, in order to better cross blend between these frames, what Matteo does is separate all the frames into even and odd frames. In order to do that, we want to change the method from full batch into alternate batches. And if we drag and drop from image 2 and select the preview image node and hit Q prompt again, we can see that on the left we only have the odd frames and on the right we only have the even frames. And this way, by using the weighted masks and by using all these different frames that have been separated into odds and evens, we can crossfade between them effectively. Now what we need to do is duplicate this IPAdapter batch node, because the one on the left is going to be taking care of either the even or odd frames, and the one on the right is going to be taking care of the other frames. So we are going to hook up the different image 1 and 2 outputs on either one of the IPAdapter batch nodes. So image 1 goes into the first one and image 2 goes into the second one. And then I'm going to hook up the model output from the first IPAdapter batch node into the model input of the second IPAdapter batch node. Alright, we got the AnimateDiff pipeline and we got the IPAdapter pipeline. What we need now is a ControlNet pipeline. So let's go ahead and drag and drop from clip and select clip text encode. Ctrl C, Ctrl V, and place it one on top of the other. Drag and drop from the clip into the bottom one. Top one, same as always, going to be the positive prompt field. Bottom one is going to be the negative prompt field. I'm going to go ahead and copy the prompts from the previous workflow. So anime illustration of a young woman swimming underwater for the positive, and photo render 3D not safe for work nude for the negative. Then we're going to need an advanced ControlNet node. So we're going to go ahead and search for apply advanced ControlNet, because we have to apply a different ControlNet to each frame that we have. I'm going to hook up the positive conditioning and the negative conditioning. I'm going to drag and drop from ControlNet and select the ControlNet loader. And the model that we want to use in this case is the QR code monster. If you don't have it, you can find it in the description below. But where do these frames that influence the ControlNet come from? Well, from the IPAdapter weight node, because we are processing them as a batch over there. So we are going to go ahead and drag and drop from weight strategy output and select IPAdapter weights from strategy. Now we're going to go ahead and drag and drop from the weights output and select latent keyframe batched group. And then we're going to connect the latent KF to the latent KF override inside of the apply ControlNet node. But wait, we have two different images output. One for even frames and one for the odd frames. So what we want to do is duplicate this apply ControlNet advanced node. So Ctrl C, Ctrl V. Link up the positive and negatives, link up the model, which is going to be the same, and then we're going to hook up the image 1 output as an input for the first ControlNet node and image 2 as an input for the second ControlNet node. But wait, if we use the same latent keyframes batched group for the second ControlNet node as well, we're going to have the same weights that we have for the first one. We don't want that, we want the inverted weights, so we're going to drag and drop from the weights invert output. Select again a latent keyframe batch group and link up the latent KF output into the second ControlNet node latent KF override input. Then the last thing we want is to drag and drop from the weights override input and select scale soft weights. Gonna input 0.925 like in Matteo's tutorial, and I'm gonna drag and drop the CN weights for this one into the second ControlNet advanced node as well. And this is our ControlNet pipeline. Now we finally have all the puzzle pieces that we need, and we can search for a keysampler node. We're gonna go ahead and drag and drop from the model output of the second IPAdapter node into the model input of the keysampler. Drag and drop from the second ControlNet positive and negative outputs into the keysampler. And then we need a batch of latent images. So what we're going to do is search for an empty latent image. And since we don't want to calculate how many images we actually need, we are going to right click on it, go over to convert widget to input, and I'm going to select convert batch size to input. So now batch size has become an input, and the batch size comes from the total frames. The last thing that we want to change here just like we just changed the batch size into an input, is how much the weight of the IPAdapter nodes influence the generation for the AnimateDiff pipeline. So we don't have a unique weight. We have different weights depending on the mask that is being applied to the different keyframes that are being duplicated 6 times. So what we want to do is right click on the IPAdapter batch node, go over to Convert Widget to Input and select Convert Weight to Input, and do the same for the second one as well. Now, for the first IPAdapter batch, we are going to connect the weights into the weights input, and for the second one, we want to go with the inverted weights. So we're going to connect the weights invert output into the weight input. So I'm going to hook up the latent from the batched empty latent image node, and then I'm going to drag and drop from the latent output into a VAE decode node, use the VAE from our checkpoint, and since we're creating an animation, we want to drag and drop from the image output and search for a video combine node. Now we are going to change the default settings in the case sampler for the LCM that we're using. So we're going to go with 8 steps, CFG2, sampler name LCM, and scheduler SGM uniform, and we can finally hit QPrompt. And I'm getting an error because I forgot to link up the images from the batch into the IPAdapter weights from strategy node. Let's go ahead and hit QPrompt again. And here we go, we got an animation, and even if there are some artifacts that can be fixed by cherry picking the keyframes that we have and redoing them, it's flickering a bit. So in order to fix that, we can make a second pass with a different ControlNet, a ControlNet made specifically for GIFs, and passing through an IPAdapter that applies with a low strength the images from the keyframes. So let's do that. We are going to search for another IPAdapter batch. We're going to run the model from the unified loader into the IPAdapter batch node and the IPAdapter output as well. And then we're going to take all the images from our VAE decode node that compose the final animation and hook them up into the IPAdapter batch node. Then we are going to lower the weight to, let's say, 0.25. And then we're going to select case sampler, VAE decode, and video combine. Ctrl-C, Ctrl-V, place them over here. And we are going to run the latent as an input over here and the model from the IPAdapter batch into the case sampler. And then the last thing that we're going to do is apply a ControlNet for GIFs. So we're going to search for and apply advanced ControlNet. We are going to hook up the positive and negative conditioning from our positive and negative prompt field into the ControlNet, and then from the ControlNet into the case sampler. Then we're going to search for a load advanced ControlNet model, and we're going to select a control GIF node. If you don't have it, you can find it in the description below. And we're going to hook up the ControlNet output into the ControlNet input. And then we're going to use the same images as a source for the ControlNet as we used for the IPAdapter batch node. So the images that are coming out of the VAE decode node. And the last thing we want to do is hook up the VAE from a load checkpoint node into the VAE decode node and hit QPrompt. And as you can see on the right, we have an animation that is flickering a lot less. Now, there are some issues with artifacts and legs morphing into the background or into fishes, for example, but that's due to the cherry picking of the keyframes. If you were much more precise doing that, then you wouldn't have those artifacts. Like, for example, if we take a look at this more realistic base with better cherry-picked keyframes, there is no morphing, there is no artifacts happening. So depending on the keyframes of choice, you get better or worse results. But regardless of the artifacts you might get, this kind of workflow is really great because it doesn't need any pass with EBSynth or other software that you were used to if you were using an AnimateDiff pipeline before. And while it's less precise in a way, it's also a lot more consistent right out of the box. So it really depends on whether or not you want to be a lot more precise or you want to just create animations without a too complex workflow. And remember that all of this is coming from a very simple animation from an FBX from Mixamo. So it's completely art directionable. Let's say we wanted to change the perspective, for example, zoom in a bit, change the camera. and then do it all over again, once we have our workflow going, it's just as easy as exporting again the keyframes and then passing them through the first workflow and then using those keyframes, generated keyframes, as a base for the second workflow. So for example, by changing the composition in Blender and then accommodating the first workflow for space settings, for example, you can get something like that instead, or by changing completely the scene in Blender, you can get something like this instead. So all in all, powerful workflow, completely directionable, you're trading precision for ease of use, and I think that is a first good step into the AnimateDiff environment. And it doesn't require you to know a lot of the stuff that you usually have to know about in order to use AnimateDiff. As I said in the beginning of the video, big thanks to Matteo. You can find his channel over at Latent Vision and his latest video here in the description below. Check it out, it's amazing, and it's what half of this workflow is based on. That's gonna be all for today. My name is Andrea Baioni. You can find me on Instagram at risunobushi or on the web at andreabaioni.com. And if you like this video, please leave a like and subscribe, as it helps a lot with the channel, and I will be seeing you next week.